factor. And when you're factoring out the GCF, you do it in two parts. First, you look at just the coefficients, then you look at the variables. The rules for the coefficients and finding the greatest common factor is listing the factors of the smallest number and then seeing if those factors are also factors of the other numbers. So if I want to list all the factors of 15, because that's the smallest number, between 15 and 35, I would have 1 and 15. I always start with 1 in the number, and then I go up for each integer. So does 2 work? 2 is not a factor of 15 because 15 is odd. Does 3 work? Yes, 3 times 5. Does 4 work? No, 4 doesn't work. And then we're back at 5, so we're done. So these are the only factors that I have to consider for my GCF. And I always start at the biggest factor and go to the smallest factor because we're looking for the greatest common factor. So starting at 15, I ask myself, is 15 a factor of 35? No, it is not. The reason I know that is because 35 divided by 15 is not a whole number. It's not an integer. So 15 is not part of my GCF. And then I look at 5. Is 5 a factor of 35? Absolutely. 35 divided by 5 is 7. That's a whole number, so I know that this right here, for the numbers, is going to be my greatest common factor. So I'm going to write that in front. I've identified for my coefficients the greatest common factor. That's the first part. The second part has to do with the variables. Now, for every variable in the problem, you ask yourself, does each term have this variable? So there's two variables in this first problem, A and D. And if we want to see if those variables are part of our greatest common factor, we have to make sure that that variable is in both terms. So, is A part of our greatest common factor? Yes, A is because A is in both terms. Remember, when you factor out a variable, you're always going to factor out the lowest power that they all have. So right now, the lowest power amongst A and A is just A. There's no exponents there, so A to the 1 is going to be part of my GCF. And then I move on to my second variable, D. D is part of my greatest common factor because there's a D in both of these terms. Now I have a D squared here and just a D there. Now remember, you always factor out the lowest power. So I have a power of 2 and a power of 1, so I'm going to factor out D to the 1. This right here is my greatest common factor. That's how we identify it. In order to figure out what goes inside the parentheses, I start dividing and taking things out of these terms. So 15 divided by 3 is 5. If I have A to the 1 here and A to the 1 gets pulled out, there's no more A's left. If I have D to the 2 and I pull out a D to the 1, I'm left with D to the 1. Moving on, 35 divided by 5 is 7. If I factored out an A and a D, that means there's nothing left here, so that's my answer. That's fully factored form of problem number 1 in this example. All right, moving on to the second problem. Remember, this process is all about finding the greatest common factor. So, do it in two parts. First, looking at just the big numbers and coefficients. Second, looking at the variables. So, if we look at our coefficients, we have 2, 32, and 96. The greatest common factor among them should, I hope, very obviously be 2. There's only two factors you have to consider with 2, 1 and 2. Both of these terms are even, which means they're going to have a common factor of 2. Then I look at the variables. I can only include a variable in my GCF if that variable is in every term. There's no x in the 96, which means I cannot factor out an x. All right, so this is my GCF. I'm going to start dividing out. 2 divided by 2 is 1, so I'm left with just x squared. 32 divided by 2 is 16. x plus 96 divided by 2 is 48. Now from here, this should look a little bit like problem number 4. You have a trinomial here inside your parentheses. So if you can keep factoring, you should keep factoring. My a value is 1. So we're going to do the factoring like we did yesterday with a times c and see if any of the factors of 48 add together to 16. So let's add together the factors of 48, or let's list the factors of 48. 1 and 48. Does 2 work? Yes. 2 and 24. 3. 3 is going to work. 3. And if you're not sure, take this number and divide it by 3. 48 divided by 3 is 16. I think. No. 1. Yeah, 16. Then 4. Does 4 work? Yes, 4 works. 4 times 12. And I'm going to stop there. There might be more. There is, but I'm going to stop here because these are the numbers I'm looking for. 4 plus 12 is 16. That means I can use my shortcut and go straight to the factored form. I'm going to write the 2 here. X plus 4. X plus 12. So just like problem number 4, you're going to have to factor out the greatest common factor and then use a times c if possible. You're the one that's going to have to decide if a times c is possible. If you're not sure, kind of fiddle around with it. Try and list the factors of the last number. If it works, then great. If it doesn't, move on. All right, I do want to give you 2 more examples. If I can find my eraser. Literally cannot find my eraser. Got it. It's behind the computer. All right. Next 2 problems. We're going to make things a little bit more difficult, a little bit more challenging. 4 xy squared minus 32 xy minus 108x. All right, so for this one, you're starting out, you're doing the exact same process, factoring out a greatest common factor if there is one, and then, if possible, factoring using a times c. When finding the greatest common factor, you do it in 2 parts. First, you begin with the constants and coefficients, and asking yourself, is there a greatest common factor among them? And in order to do that, you always list the factors of the smallest number. We've got 4 here. There's not many factors of 4. 1 and 4, 2 and 2. Starting with the largest of the factors, we're going to check to see if 4 is also a factor of 32 and 108. And if you're not sure, you got to use a calculator, right? 32 divided by 4, is that a whole number? 108 divided by 4, is that a whole number? If both of those numbers are, in fact, whole numbers, it means that my greatest common factor is 4. And in fact, it is. Then, second part is variables. Remember, a variable can only be part of my greatest common factor if it's in every term. So, if we look at our x's, I have a single x here, a single x here, and a single x here. X is in every one of my variable, or every one of my terms. So I know x is going to be part of my greatest common factor. Then I look at the y's. Y squared, y, and no y. Because this term is missing a y, it is not going to be part of my greatest common factor. Don't get tripped up if there's more than one variable in these terms. You're only going to factor out variables that are in every term. So this right here is my greatest common factor. And from there I start dividing out. 4 divided by 4 is 1. If I have 1x and 1x gets pulled out, There's none left, so I'm left with just y squared. Minus 32 divided by 4 is 8. I have 1x here, and it gets factored out, and I'm left with y. Minus 108 divided by 4 is 21. No, 27. And that x gets factored out, and that's what I'm left with. Sorry, I'm checking my math. 80 plus 28. Yeah, okay. Now, if we look inside this parentheses, we're going to check to see if we can factor using the a times c method. My a value is 1, so I'm going to be able to use my shortcut. I'm going to list the factors of negative 27 and see which of them, if any, can add together to positive 8. Because this is negative and my b value is also negative, it means that the bigger factor, when I list these factor pairs, needs to be negative. Because when I add them together, it has to be a negative number. And that only happens whenever the bigger number is also negative. So 1 and negative 27. 2 does not work. 3 does, however. 3 times negative 9. 4. 4 does not work. 5 doesn't work. 6, 7, 8. Yeah, that's it. So do any of these numbers add together to a negative 8? No, they do not. So that means that I can't factor it any further, and this right here is my answer. But if you end up with a trinomial in this parentheses, you got to check. You have to check to see if it's possible for it to be factored any further. Just like problem number 4 from yesterday in the second example that I did here. Excuse me. It's not Corona, I promise. Not that it matters. Can't get it over the internet. All right. Last example. 45 c to the 4th minus 280 c to the 3rd plus 160 c squared. C squared. All right. Start off with the greatest common factor. List the factors of the smallest coefficient and check to see in descending order if those are also factors of my other numbers. So if I'm going to list the factors of 45, I have 1 and 45. 2 doesn't work because this number is odd. 3 is going to work. You've got 3 and 15. And the way I'm figuring that out is I'm doing 45 divided by 3, and I'm getting a whole number. 4 doesn't work. 5 obviously does. 5 times 9, and 6, 7, and that's it. So, in order to see what my greatest common factor is for the numbers, I'm going to start at 45 and check to see if 45 is a factor of these numbers as well. And I do that by doing 280 divided by 45. That's not going to be even or a whole number, I don't think. These numbers are a little big for me to do in my head, so 280 divided by 45. It's a decimal, so this is not going to be part of my greatest common factor. What about 15? 280 divided by 15, also not going to work. 9, 280 divided by 9, decimal. 5, well, any number that ends in 0 is going to have 5 as a factor, so 5 works, and it works for this one as well, so my greatest common factor is going to be 5 for the numbers. So I'm going to pull a 5 out. You then look at your variables.